ego issues, discovery issues, timing, credit, and simultaneous discovery is something we need to understand because competition is very severe and in the science arena. And to give you another example of this on a also well-known discovery, a modern discovery about the structure of DNA. And many people simply think of Watson and Crick, and there's more to the story. There's quite a bit more to the story because Friedrich Miescher in the late 1800s actually discovered DNA. He pulled it out of the wounds, out of pus from wounds, and thought that it was a new material, not a protein, something quite different from a protein substance. And he was working at that time with another researcher who was more up the food chain, as it might be said, in the sense that in Europe at that time, and actually right on into the 1960s and 70s, many times institutions would have one person in charge of most of the science in a chemistry or physics department or in a medical department. And the person who was in charge of what was going on didn't think that this work was worth all that much and that Miescher just simply didn't have the right stuff to get this published. Eventually it was published. And over this period of time, it lay fallow or lay dormant in effect, in a journal that wasn't very popular until the 1940s, when Oswald Avery, Halifax, Nova Scotia, his father was a minister. They moved to New York City when Oswald was a teenager. He went to Colgate University and eventually went back to the Rockefeller Institute, as it was called at that time. It's now Rockefeller University. And he took that DNA that Miescher had discovered, not the same DNA, but the idea of DNA, and found that it had replicating capacity, and made a very important paper that many feel should have been the subject of a Nobel Prize, but it turned out that it didn't work out for Avery, although perhaps it should have. And again, simultaneous discovery happens. So Avery's paper and his colleagues' paper triggered interest in trying to understand what the structure of DNA was. Well, one of the persons involved with this investigation was Linus Pauling, a really famous chemist who had already received a Nobel Prize for his work on the chemical bond and was to receive the Peace Prize later on in the 1960s for his work pushing against the use of atomic weaponry. Pauling was a scientific giant, perhaps on a par in effect with Einstein, or certainly in that general high category. He was working on the project. He published a paper which turned out not to be correct. It was a good try, but it wasn't actually the right answer as it was. And Pauling was working with molecular models. The molecular model motif for working with how these molecules were all put together was seized upon by Watson and Crick, who eventually did get the structure correct. Now, Watson and Crick, as it turns out, were, and I don't mean to disparage them because of they have a giant legacy, but they were at the time scientific nobodies. Crick had not yet received his PhD. Watson had. He was much younger. He was in his early 20s. But they worked out the structure at Cambridge. And they were in great fear that Pauling, the scientific giant from the States, was going to upend them and get the structure of DNA. Well, it turns out they beat Pauling to the punch, as it might be said. And here are Watson and Crick discussing their victory. There's a large story associated with this that you might like to look into. And Watson wrote the book on this particular point. So here was their paper, and as is appropriate in a paper, to have a slightly understated first sentence, namely that has considerable biological interest. And it certainly had considerable biological interest. There is absolutely no question about that. Another quote that came from the paper: "It has not escaped our notice that this may have possible copying mechanism for the genetic material." Well, that attracted chemists and biologists and medical people to this research area. There's no question about that. And credit eventually did go, and does seemingly still go, almost solely to Watson and Crick. However, Rosalind Franklin gave some very important data, or uncovered some very important data, some very important X-ray crystallographic data, and never really received the credit that many people feel she deserved. A few years ago, there have been a couple of biographies of Rosalind Franklin. Unfortunately, she died of cancer at age 37 before the Nobel Prize was actually awarded. Maurice Wilkins is a third party in this Nobel Prize event. It turns out that, as many may know and many may not know, you can only have 3 names, and they have to be of living people for the Nobel to be awarded. Wilkins was a kind of a silent partner in this enterprise, and he was really the research coordinator with Rosalind Franklin, although she worked really quite independently at the time. And Franklin came up with an X-ray photograph, as it has been called, showing a particular symmetry pattern in a kind of an X arrangement that Watson and Crick eventually found to be important, and they got the idea that this must have something to do with the double helical structure. And as you'll see, credit is being given in this very first line, credit to Pauling for his paper that was not correct. They were very gentle with it, and they didn't disparage it in any way, but they noted that Pauling had tried to had published a paper that didn't happen to have quite the right structure. And so credit wound up being given to Watson and Crick almost exclusively. Those are the pair of names that pretty much everybody associates with the discovery of the structure in DNA. And there are, I think, ego issues, and this is a personal view. Pauling was a giant scientist of giant capacity for roughly 60 years of his career. And in 1987 gave a series of lectures at Cornell University that celebrated his 50 years since he gave the earlier Baker lectures, and it was on the chemical structure of various molecules. He didn't really respond or he wasn't talking at that time about DNA at all, but that's just a picture that a colleague of mine took at the time, and he was a very entertaining lecturer. In another area, and I don't know quite where this took place, but he was talking about DNA in a piece that is from the internet. And he takes about a minute or so to listen to him, and I think it's important to listen to what he says and how he actually says it. So this is Pauling speaking probably around maybe 1990, something like that. He passed away in 1992 at age 92. He was born in 1900.
Well, I was very interested in DNA. I was still working on proteins in the 1940s, but I thought it would be nice to determine the structure of DNA. And I was working on the problem at the same time Watson and Crick were. And I thought in the course of time I'd determine the structure, but I got skinned out of it by Watson and Crick, who got beat by Watson and Crick. I wasn't working very hard at it. I had some other problems going through, and I was handicapped, of course, by not having access to the experimental information that they had. The X-ray photographs, I tried to get hold of the X-ray photographs that Rosalind Franklin had made, and I couldn't get them. I wrote trying to get them, but didn't succeed in getting them, whereas Watson and Crick had them and were able to analyze them.
Now, this is just a personal opinion. I have the utmost respect for Linus Pauling, but I think when you listen to how he sounded a little nervous in talking about this particular project and how he got skinned out of it or got beat by Watson and Crick, there was another phrase that I thought was really very interesting, and I don't know the efficacy of this particular phrase. He was saying, I wasn't working very hard at it. Maybe he was, maybe he wasn't. My suspicions were that, and I think many people's suspicions were, that he really was working very hard at it. But it simply shows how everybody, even the giants, had the competitive spirit. And this is certainly the case in scientific discovery.